Alright guys, here we go. This video is going to be part 2 of finding zeros, so I'm going to still put a title to this. And if you hear a little bit of background noise, the dryer is on, or washer, I'm sorry. So finding zeros, remember these are the X intercepts. We are still continuing to talk about quadratics, quadratic functions. Sorry about the washer. Alright, so here we go. So in the last video, part 1, you should have taken from that of how to use the calculator and do the graphing method. So again, in video 1, I've done graphing. And then the other thing I started with was the quadratic formula. So please watch that. Again, it's like 32 minutes, so I know. But just skip around, do what you need to do, and definitely practice and make sure you're comfortable with these two methods. So in this video, I'm going to focus on factoring and taking the square, and if I can also, I'll show you a little bit more graphing or a trick of how to figure out how many zeros there are for a quadratic. Alright, so remember, for graphing, I'm going to start off with this one. Give me 1 second. Okay, so this particular problem, let's start again. So it's 7x squared minus 31x minus 20. Alright, so as you can see for this one, I'm going to circle it. The a value is greater than 1, alright? So for this one, when the a value is greater than 1, just to be clear, is you have to get the factors of a and c. So again, when a is greater than 1, you have to get the factors of a and c term. Okay? So I'm going to circle also the 20 in the back and then the 7. So the only factors, because 7 is prime, is 1 times 7. And the factors of 20 are 1 times 20, 2 times 10, 4 times 5, okay? So this is where we put those two big sets of parentheses, like that, right? We also can set this equal to 0 because we want to solve for what the X intercepts are, or the zeros. But again, all I know is since I have 1 and 7, I'm going to put an X, a 1X here, and a 7X here in the front. Remember, what we're doing with factoring is called the FOIL method, and I'm going to do guess and check. Guess, check. Okay? Again, I can't stress to you enough that come to the help sessions Tuesday and Thursday night to get some support from 6 to 7 or 6:30 to 7:30. I usually stay there from 6 to 7:30. But again, come so you can ask some specific questions. But here we go. So we have x and 7x, and if you're thinking to yourself, well, Miss Mosley, why didn't you put the 7x in the first parentheses and an x in the second? It doesn't matter, because when you multiply both of these two terms together, you're still going to get a 7x squared, so it doesn't matter what order you put that. All right, so now we have to play with these different factors back here using guess and check to try to get this negative 31. So let's just see. If we try 1 and 20 in this position, notice what you'll get. Remember, to get the negative 31x, you have to just do the outer and inner term. So if I do x times this outer term back here, 20, this will give me a 20x. If I do my inside, my I, this gives me a 7x. Now if I add that, I get 27. If I subtract it, I get 13x. And as you can see, that's not going to be a 31. Okay, so I'm going to just delete all that away. I know I get to cheat a little bit. So now I'll put the 20 here and the 1 there. And again, if I do my outer term, I get a 1x. If I do my inner term, I get 140x. And we know that's not going to give us a 31. So basically, we will cancel this one out. All right, and let's delete that away. I got to also go back and delete. I cut off some stuff. That's why I do the back. Okay, arrow. All right, so we're back to here. This is a 4. So now let's try 2 and 10. So if I put 10 here and 2 here, again, x times 2 will give me the 2x. 10 times 7x will give me a 70x. That will never give me a 30. All right, so I'm going to go ahead and delete that off. And then again, if we try 2 here and 10 here, this will give us a 10x when we multiply. That's what I'm doing. And then 2 times 7x will give me a 14x. If I add that, I get 24x. If I subtract, I get a 4x. So that also isn't going to work. All right, so now let's try 5 and 4. Okay, so what if I put 5 here and I put 4 there? Alright, so from here, as you can see, let's do our outer. So that'll give us 4x. And then our inside multiplying 5 times 7x is 35x. So again, if you subtract these two, see guys, you'll get a 31x. Now remember, you want a negative 31x for your b term. So where should we put our negative? Well, we should put it on the bigger number and put a plus on the 4x, because negative 35x plus 4x will give us a negative 31x, okay? So the 35 came from right here on the inner. So right here is where I'm going to put my negative. On the outside is where the 4 came from for the positive 4x. All right, so now just to double check, the last thing is, of course, is your L, right? So if we multiply this negative 5 times positive 4, that does give us the negative 20. And this is the right combination. So it's x minus 5 and 7x plus 4. This is factorable. Set it equal to 0. So if we want to find out what our x-intercepts are, we're going to set each of these parentheses or these binomials, right? We're going to set them equal to 0. So x minus 5, set it equal to 0. Solve for x. So we add 5 to both sides. So as you can see, x is equal to 5. That means one of my intercepts is at 5, 0. And then for the 7x plus 4, set that equal to 0, negative 4, 7x is equal to negative 4, x is equal to, again, I'm dividing by 7 on both sides, negative 4 sevenths. So one of my other x-intercepts is at negative 4 sevenths, 0. So just to be clear, what the takeaway from this is, like I said in video 1, we were doing quadratic formula, right, where we take the a, b, and c term, and then I also showed you, hey, just plug this in and graph and then do second calc. But you can also factor your, with guess and check, you can factor and find your x-intercept. So this is the third method that I'm showing you. All right, so let's do another one. How about this one? P squared minus 5p minus 14, okay? So as you can see, this one, the a value here, even though you don't see it, a is equal to 1. So for this one, when a is equal to 1, you don't need to do the factors of the a term and the c term. You just start right into your two sets of parentheses. Again, I'm setting equal to 0 to find my x-intercepts or my zeros or my roots. So I'm just going to put a p and a p. And just so it's not confusing, I'm not turning this into a negative. I'm just letting you know that there is a 1 right here. I was in the erase mode. There's a 1 in front of that p squared. All right, so when there's a 1, you just have 1 times 1, right? So that's why I'm putting p times p, which will give me p squared, right? Now for 14, the factors of 14 are 1 times 14 and 2 times 7. So which combination would give us something with a 5? And it's the 2 and 7. So I put a 2 here, a 7 here, but again, we want a negative 5p, and I'm telling you to put the negative on the 7 and a plus on the 2, because again, the rule of integers say that if you have a negative plus a positive, you subtract, keep the sign of the bigger number. Okay? All right. Got it. All right, so that's it. And then just to double check the L, we have a positive 2 times a negative 7 is that negative 14. So if you FOIL this out, and I'm just going to show that to you real quick. If you do p times p, that's the f, that's p squared. If you do p times the negative 7, that's the O, the outer term, that's a negative 7p. If you do the inside, you get the positive 2p. If you do the last, you get the negative 14. And again, the O and I terms always combine to give you your B term, and there's the negative 5p. So that's just a review of the FOIL method. And again, this comes from Unit 6 when we did polynomials and factoring. All right, so now let's finish off and let's solve for our x-intercepts. So we're going to do p plus 2, set that equal to 0, p is equal to negative 2, again just do inverse operation, and then you got p minus 7 equal to 0, inverse operation here, p is equal to 7. So your two x-intercepts, one's at negative 2, 0, one's at positive 7, 0. So again, when the 1 is there for a, it's so easy, right guys? All right, let's do it again. I'm just going to scroll all the way down to here. All right, let's do another one. 2b squared plus 17b plus 21. All right, again, our a value is equal to 2, so I'm going to get the factors of my a term, 1 times 2, the factors of 21, 1 times 21, 3 times 7. All right, so do my two big sets of parentheses, set it equal to 0, and I have 2b and b, which combination will give me a 17. Well, between you and me, I'm going to try the 7 and 3. So remember, if I put the 7 here and the 3 here, let me scroll up a little bit. So when I do my O and I, this right here, 2b times 3 is 6b, and this right here, 7 times b is 7b. That's going to give me a 13b. If I add them, if I subtract, that's going to give me a 1. So I really don't want that. So let's change this and this. We're going to just change we're going to put the 3 here and the 7 there. So if I do 2b times 7, guys, I get 14b. If I do 3 times b, I get 3b. Boom. See, when I add that together, that gives me 17. And I want them both positive because it's a positive 17b. Easy. So these both have to be pluses, and now let's solve for our x-intercepts. So I have 2b plus 3 equals 0. Subtract 3, because you always do your addition or subtraction first. 2b is equal to negative 3, so b is equal to negative 3 halves. So one x-intercept is at negative 1.5 comma 0. The other one is just going to be, do y'all see how easy this one is? It's just b is equal to negative 7. So the other one's at negative 7 comma 0. So that's 3 examples there. Let's do one more. Again, this is the factoring method, which there's quite a few of you that are very, very good with it. So again, if your first mind is, hey, I see a quadratic like this. This is my last one, right? And it says, hey, find the 0. You know, I'm also going to show you this. Find the 0 of the function. Again, this is a y. You could say, hey, I'm going to graph it. So you say, hey, I'm going to plug this. Remember, you got to use x's for the calculator. So you could just graph it, right? And then do the second calc, left bound, right bound. You could just graph it. Or if you're solving, right? If you're solving, set it equal to 0. And that's where you say, hey, I want to use quadratic formula. Hey, I want to factor. Hey, can I take the square? But see, you can't take the square on this, right? So again, the method I'm showing you right now, the method I'm showing you right now is factoring. So we're not going to use quadratic formula. So let's get started. So here, a is equal to 5. A is equal to 5. So I'm going to get the factors of the a term, 1 times 5. The factors of the c term, 1 times 18, 2 times 9, 3 times 6. I think that's all of them. And now, in the front of my parentheses, I'm going to put 5p and p, and I got to play with these factors. I know I'm not going to do 1 and 18. I'm trying to get a negative 1. So which one would give me I bet you I should do, let's do 6 and 3. So I'm going to tell you what my brain was thinking. My brain was like, hey, if I put the 6 here and the 3 there, let's just see. See, that's going to give me a 15p, and this is going to give me a 6p. Now, that's not going to give me a 1. If I add it together, I get a 21p. If I subtract, right, I get a 9p. So now I'm going to switch them. Remember, I'm just guessing and checking. So now, and let me also make this comment. You know, you guys can listen to me out, whatever you want to do, but some of my really sweet kids get it, right? Is you don't want to go into it negative, like, oh, you know, I don't want to do this, it's too long, this. Well, if you do that, right, I forgot which one I put. Oh, I think I'm going to put the 3 here and the 6 there. Because you already have things that you have to do, like the guess and check method. You're going to have to play with multiple factors in different positions to get the outcome you want. So just be positive with it. Don't sit up here and say, you know, it's too long, it's too much. And then if you keep saying, I don't get it, well then you're just not going to get it. So this is 27p. And this is a 33p, so that didn't work out too well for me. So again, we gotta keep going, right? We just gotta keep going. But I appreciate those of you that are just like, you're more into, I guess, getting the outcome, right, of trying to solve it. So just get in that, keep that energy for solving things, as opposed to like what's taking too long, or, you know, all that good stuff, you know. All right, let's see. As you can see, neither combination of 6 and 3 in different positions helped. So let's do 9 and 2. Well, I know I'm not going to put the 9 on the outside. That's going to give me a 45. So I'm going to put the bigger 9 there, 2 there. Look, guys, this is a 10p, and this one is a 9p. Boom. Subtract, that gives me a 1. But I want a negative 1p. So I'm going to put the negative on the 10 and a plus on the 9. So we'll put a plus here and a negative there. Now when I solve, by setting both of those equal to 0, I get 5p is equal to negative 9. Sorry about the kid. Negative 9/5. So one of my x-intercepts is at negative 9/5 comma 0. It's probably like negative 1 point something. And then, of course, the other one is p minus 2 is equal to 0, so p is equal to positive 2. Boom. Okay? So here are your two x-intercepts. I hope you understand now how to do the factoring method. Okay? If you ask me, what preference I have, I'll be completely honest with you. I don't have one because, and again, my teacher taught it 5 different ways. So there's also completing the square. And so I'm just telling you that you just want to be comfortable with any of them, because the more tools you have, when you take an SAT or an ACT exam, the more strategies you have to attack math problems. So that's why you want to be positive. All right, so that's factoring. So let's talk about taking the square. And I'm going to just make these up. All right, so here's the taking the square method. This is the last one I've taught you. And again, this one usually you use when something is in vertex form. Okay. The next video, I'm going to go over axis of symmetry and finding the vertex, and then a little bit of graphing by hand. All right, here we go. So if you get something that looks like this, I don't know, I'm just going to make it up. Minus 4 squared plus 8 equal negative 7. Okay, so if you get something like this, again, this is taking the square. All you're trying to do, remember I stressed it so many times, we know that PEMDAS is for this way expressions. But when you're solving equations, you do S up to P. So the first thing I'm going to do is take care of the addition and subtraction. I'm trying to solve for this x. But remember, I'm going to get 2 x's, right? Why is that? Because I'm a quadratic. So I should get 2 x-intercepts. All right, so here we go. So S and A, take care of that first. Well, I notice here, right, that I have a what? A plus 8. So I got to do minus 8, minus 8. Boom. Now I have 3x minus 4 squared. Do not try to distribute. This guy is in prison with this other guy, held tight. Here's the prison guard, right? Nobody can break him out yet. So now this is negative 15. And then I'm going to divide by 3 to both sides. Just showing you the steps. Because again, after I took care of the addition and subtraction, okay, then I had to do multiplication or division. So I had to divide by 3 to both sides, and now I'm here. Now, can I tell you this is going to be such a disaster? I already can tell you why. Because it's equal to a negative 5, you see? So if you take the square root of this side, guys, and the square root of this side, remember the square root and the square is going to cancel out. That binomial will fall out. Now that x is free with this other guy. But the problem is there's no such thing as plus or minus a negative square root. When you get into Algebra 2, it talks more about imaginary numbers, right? So this was just a bad problem because I messed it up. I made it up, and not messed it up. I did it right, but I made it up. So can we go back here? I'm just going to adjust a little bit, and let's make this a bigger number. Okay, now I don't want to clear the whole canvas. We're just going to make this like a positive number. Okay, that's how I'll fix it. I'm going to make this a 25. Can y'all bear with me a second? So, still going to learn. So, I'm going to go back here. I'm going to delete that negative 15 right here. And again, when we go back and we minus 8 from both sides, this is a 25 now. This is going to be, I believe, 17. Yeah, 17. Divide by 3. Y'all see that I fixed it? And now from here, let's erase this side and this side. My son is having a good time. Is 17 divided by 3. Let me get that decimal for us real quick. So if I have, 17 divided by 3. See, that's 5.666 or 5.667 repeating. So now, okay, I'm telling you that over here, after dividing by 3, this is 5.67. You see that? You still, again, we had to take the square root, then the square root. So where we're at now is that this falls out, and then remember, we have plus, minus, and I got to take the square root of 6.7, 5.67. So I go back here, that, and 5.67, enter. So it's 2.38. plus minus 2.38. And don't worry, the next one I make, I already see what I have to do, so we don't have that issue again. So plus minus 2.38, and we add 4. And I know this is going to look really weird, guys. Just relax. Add 4 over here. So what are your two x-intercepts? Well, it's a positive 2.38 plus 4. That's one of them. And then the other one is a negative, because of this right here. The negative 2.38 plus 4. You see? So your two x-intercepts, this one is 6.38 comma 0. And this one's like, I think, negative 2.38 comma 0. You can just plug in the calculator and see what you get. Let me double check the bottom one. I'm very confident on this one. Let me check that one. So what is negative 2.38 minus 4? Negative 2.38 minus 4, right? No. Plus 4. Sorry. Negative 2.38 plus 4. Let me just go over here and change that to a plus. You can type over. Hit 4 again just to be careful. Oh, see? I knew it. Because of that decimal, the change. Give me a second. So positive 1.62. Erase that. Guys, this is positive. Oops. Positive 1.62. Okay. I'll make a better one the next one. Okay, here we go. Okay. Alright, guys. Make a better one. Alright, so from here, again, sorry about the kid and all the noise. These two. What can I do? Alright. So, I'll make up another one. We'll do better. Let's do 4 x plus 2 squared minus 8 equal 36. See what happens. Here we go. So first step again, add 4. Remember, this is taking the square. Add 4. Sorry, add 8. I was looking at the 4. 4x plus 2 squared equal. So this right here should be a 44. Yeah. Divide by 4. Divide by 4. So now we have x plus 2 squared equals 11. Take the square root. Take the square root. And again, in this step here is the one where you know that the square root and the square cancel out. So you have x plus 2 is equal to plus minus the root of 11. You see that? So x plus 2 equals, now in this step you could grab the calculator and say, hey, what's the square root of 11? So I'm going to go here and say, hey, the square root of 11 is, and if anyone ever wanted to know, I can teach you how to find ones that are unperfect squares, how to approximate them without a calculator if you ever want to know. So this is 3.32, but I can show you how to do it without a calculator. Okay, whoops, I hit the wrong one, wrong thing. So this is plus or minus 3.32, and then minus 2, and again, I know it looks weird, minus 2. So your two x-intercepts, one is at positive 3.32 minus 2. Well, you know that's 1.32, right? I mean, just think about money. The other one is negative 3.32 minus 2. That's negative 5. Is that right? Yeah, negative 0.532. Double check those for me, but I think that's pretty good. So here are your two x-intercepts. All right, so that's taking the square. Again, if it's in vertex form, if I can tell you on the test, you are going to be asked specifically, use quadratic formula to solve. And so you got to use a quadratic formula. I'll provide it to you. I'll say, take the square, you see. But just know that if you see a problem, just saying, that looks anything like this, I don't know, you know that you're going to take the square. And if I say factor, then make sure you factor and show the steps for factoring, like that. And then the last one is, you know, graphing. But in the same regard, if I just say, hey, solve, find 0, right? And I don't specifically say to use a specific method, then do whatever you want. Do whatever you're comfortable with. If you're like your first brain, I know like Damone, his is like, he likes to factor quick and he does it good. I haven't found anybody that likes quadratic formula yet. So, but you have to take the square if it's in this form. Okay, all right, so that I'm going to end this video. See, this one was short and sweet. All right, I'm going to end the video here. Again, this video was about taking the square. It was also about factoring. Oh, let me show you one really quick thing. Remember I told you I'm going to show you a trick on how to figure out how many zeros you have before you start a problem. So let me just make up something real quick. Let me try this one. Well, let's say you had something like this, right? So I'm going to subtract 6, and I'm going to get 3x squared plus 12x, and that's a 12, equals 0. All right, so here's how you know how many actual zeros or x-intercepts you have, right? Well, remember how you have the quadratic formula, right? B squared minus 4ac divided by 2a. Where there's this thing that they'll talk about in Algebra 2 called the determinant. Well, the determinant is this whole little expression under here, right? So let me show you a trick. If you take the determinant and you set it, there's some how do you say, there's certain types of rules that if you solve this and you get a certain value with this, whatever this calculates to be, it'll tell you how many zeros. So it'll make sense in a second. Ready? So we know our A is 3, B is 12, C is 12. So very carefully what I'm going to do is plug in my A, B, C into this. So I got B squared minus 4AC, ready? Equal, I'm doing the substitution. So we got 12 squared, because that's the B, minus 4, and the A is 3, and the C is 12. So let's calculate what our determinant is. Again, one more time. This thing here, this whole little piece that goes in the quadratic formula, this is called a discriminant, not determinant, discriminant. Doing this from memory. It's called the discriminant. So let's calculate this. So we got 144 minus, remember I told you multiply this, so 12 times 3 is what? 36. 36 times 4. 144 again. Yep. No one. Yeah, 12. And then plus 2, yeah. 144. So guess what? I just got 0. So our B squared minus 4AC is equal to 0. Now watch this. I'm going to show you something on the internet. Ready? Discriminant. Like that. Let me just see what comes up. Let me show you this. It's so cool. So look at this screen right here. Ready? So the discriminant. If you ever get to the discriminant, after you plug in, you see how I'm showing you the same thing? Here's your ABC, plug it into this formula. If the discriminant is greater than 0, so if you get a 2, a 3, a 5, a 10, doesn't matter, bigger than 0, you have 2 real solutions. That means you have 2 x-intercepts, 2 solutions, 2 roots. Get it? 2 zeros. If the discriminant is equal to 0, there is only 1 real solution. So it means it only has 1 x-intercept, 1 root, right? 1 0, 1 x-intercept. So if it's greater than 0, 2 x-intercepts. If it's equal to 0, 1 x-intercept. And if it's a determinant or a value less than 0, so it's a negative number, guys, then it's imaginary. It has 2 imaginary solutions. So watch how I prove this to you super quick. Ready? So we go to the calculator super quick. And again, the answer that we got was equal to 0, right? So if we just graph that function, I forgot what it was. Hold on, let me think. I think it was 3x squared. Whoops. Alaric. 3x. I'm not going to pause the video to talk to him because I'm trying to hurry. It's the end of the video. 12x. And I think it was plus a 12. Ready? So now watch what happens when you graph this. Bet you only have 1 x-intercept. Boom. Do you see that? See how he's just sitting on the x-axis at one place? So there's only 1 x-intercept. So that was just a quick trick. Again, one more time, just in case people are like, what? What I'm saying to you, okay? Shh, all right. What I'm saying is, I'm going to show you one more time. Is this you? Oh my goodness, what I do? Great, everything's crazy. Okay, is this useful for you right now? Not really, but guess what? It's something new that will come in Algebra 2, so you'll be asked this. All right, here we go. Ready? So what if you were given this? 153 equal negative 9. Give me a second. So again, real quick. So we're going to add 9. Add 9. So 2x squared minus 2x. I don't even know what this is. Threw away. I think this is 146. Let me check. So I'm going to go back to second quick. So what is 153 minus 9, I think? Yeah, 144. Is that what it was? Yeah, I'm subtracting. 153 minus 9. Okay, so according to that, it's negative 144. Equals 0. Okay, so again, our A is 2, our B is negative 2, our C is negative 144. And again, what I'm talking about is if you take this discriminant formula. All right, so here we go. So for the discriminant, right, I'm going to plug in the respective values. So I have B squared, so I have negative 2 squared minus 4. My A is 2, my C is negative 144. Again, what does this do for you? What it does for you is it helps you to figure out how many zeros or how many x-intercepts you have. Okay? Okay. So we know 2 squared is 4. So we have 4 minus, and then I'm going to multiply this part together. So this is going to be 8. This is going to be 8 times negative 144. Okay? So if I grab the calculator, and I do 8 times negative 144. Wow, there's negative 1,152. So right here, look guys, negative 1,152. See how you're going to add that? So the answer is going to be what? 1,156. Remember, like I just said, if it's greater than 0, there are 2 x-intercepts. So if you go and you graph this, you're going to get 2 x-intercepts. Okay, I'm going to end the video here.